Hi everyone. So we continue on chapter 3. So basically I centric at chapter 3 because we will learn chapter 3, but just part of the chapter 3 because we only learn on the vectors part and not the motions part, where we will learn these things later on after we learn in chapter 2. So actually on chapter 3, from the textbook we can learn some things that related to vectors. So what is vector? Okay, so we will look. So on chapter 3, these are the units of chapter 3, which means we will learn some things that related to vectors and their properties. Of course, when we talk about vectors, it must involve components of a vector. In order to get components, we must make sure the components will lead us to get the resultants, which means we have a magnitude and directions. And for the purpose of scalar and scalar, also vector and cross product, so that is the added value to this chapter, because in order to understand the concepts of vector, so we also learn about scalar and vector quantity for the dot and cross product respectively. So basically these are the vectors and their properties. The vectors, at first we learn about scalar quantity. The scalar quantity has only magnitude. It has magnitude, while for the vector quantity it has both magnitude and also directions. So the examples of the scalar quantity such as length, area, volume, speed, mass, density, maybe pressure, energy, work, and also power. But while for the vector quantity, we have a displacement, directions, velocities, acceleration, momentum, force, a lift, a drag, a thrust weight, and you have a lot of more vector quantities. And so we can write down this one as a vector quantities. Why? Because vector has both magnitude and directions. So basically a vector is represented by an arrow. Okay, it's just not a normal arrow, but if we try to discuss about vector A, so we should put an arrow at the top of a vector A, so like this. So we can always write down as vector A. Like for examples, I write down here as vector A. So normally when we try to type it on our desktop or laptop, or maybe a more digital part, so we can always bold the consonants for us to understand this one is a vector. But when we write down using our own hand, our own pen, so we cannot easily or consistently uh, put an arrow or get the vector to be bold. Okay, kita tak boleh nak all the time kita nak boldkan vector itu, so therefore kita letakkan arrow ataupun anak panah di atas consonant ataupun vector yang kita nak jelaskan. So the vector we put arrow, or maybe we can either italic or get it bold. So macam saya cakap tadi, kita boleh letakkan dia dalam bentuk italic ataupun bold. But normally bila you do handwriting, your own handwriting, kita boleh just put a simple arrow, so that we know there is not a simple A, but this is a vector A. So this is the equality of two vectors. The vectors are equal if they have the same magnitude and the same directions. So what is actually vector when you are given a figure like this? So you can see now an arrow is pointing towards the same directions. Okay, so it's pointing towards the same point, and of course if you can measure the length of the arrow, okay, if you can measure, you can see here this arrow and also this arrow have the same length. So when we measure that arrow, so that arrow will give you magnitude. The measurement of the arrow is magnitude, and of course it's pointing towards the same, and that's why these are the vector. Okay, that's how you interpret vector. So vector is about measurement. Vector is about length that you put the directions to the length. So that is simple words how to explain vectors. So when we try to deal with the vectors problem, definitely the most important thing when you try to deal with vector is you have to know what is the resultant vector. So as stated here as R is known as the resultant vectors. And how can we get resultant vectors from a certain vectors? So vectors also can be add and can be subtract. So for example, we have to add vector A plus vector B. Okay, so in order for us to get resultants of vector A plus vector B. In this case, we may add the vectors graphically. Graphically means we can draw the vectors itself. Okay, how to draw a vectors? So again, we should use a very precise. Let's say vector A is here, like this. Okay, using a ruler. Of course, this is vector A. So vector A has its own length that we consider that as magnitude, and of course is pointing to the right, okay, horizontally. And if you can see here that vector A now have been added to vector B, or vector B can be added to vector A. So the terms we use in the drawings of the vector is what we call as tip to tail method. So what is tip to tail method? The tip to tail method will give you or will give resultant vectors from adding the vector. How to add a vector using tip to tail method is very easy, because when you try to add the vectors, you must do it, okay, like this. So if you want to add vector A, okay, arrow, plus with vector B, so meaning that you should draw first the vector A. When you try to draw a vector A, so you must draw it with a scale, meaning that if the vector A is considered as 5 meters, so you cannot draw 5 meters on your paper, definitely, but you can put scales. Okay, maybe 1 centimeter is equivalent to 1 centimeter equivalent to 1 meter. So therefore, you can just draw 5 centimeters on your paper in order for us to understand the concepts of vectors addition. And after you draw the vector A with the perfect length and of course the perfect conditions, now a tip to tail method will ask you at the end of vector A, you begin to start to put a vector B. So vector B is going this way at a certain elevation of angle over here. Maybe it's not stated here, but right now, how to get the resultant? So the resultant is where the beginning of vector A until the end of vector B. Remember, at the beginning of vector A and at the end of vector B. So that will give you how to add the vectors graphically using a tip to tail methods. But this is very useful methods because that is not only considers when you are considering adding 2 vectors only. Okay, if we do have more than 2 vectors, such as we have C, we have D, we can also always use tip to tail method, because in here, for example, the resultants of A plus B plus C and plus D is based on, here we get A, and at point A we add vector B, and at point B now we add another vector C, and at point C now you do an imaginary Cartesian coordinate in order to draw a vector D, and at the end you start at the points of the initial point of vector A until the last point of vector D. So that is the tip to tail methods. So afterwards you can measure the length and of course the angle in order for you to write down the vectors or the resultant vectors. So this basically is a very good example on how to determine a resultance vector C when you adding vector A to vector B. So you can see here the description of vector A is 5 meters. Like I'm saying, we cannot draw 5 meters, okay, on your paper, on your A4 paper. For example, you cannot draw a 5 meters, okay, because when you're drawing using graphical methods, you must draw it properly, you must draw accordingly to the scales. So therefore, if you want to write down 5 meters, it's very impossible to draw on your paper, and then we of course we need the scale. So 1 centimeter is equivalent to 1 meter, therefore we can draw 5 centimeter for the A, and of course the angle is 60 degree above the x-axis. Where is the x-axis? Over here. This is your x-axis, and of course this is your y-axis. Okay, you have x and you have y, so 60 degree, follow all the rules for the vector A. And afterwards, if you want to add, because the vector asks you what is the resultance of vector A plus with the vector B. What is the resultance? So therefore, you have to use the tip to tail method again. Okay, draw the imaginary line of the Cartesian coordinates over here, just like we did here. Okay, right now you draw the 4 meters for vector B and 20 degree above the x-axis using the same concept that we draw vector A. And at the end of it, okay, you can just take this point, okay, at the beginning of vector A until the end of vector B, so that we can have its magnitude. Okay, using the ruler and of course the protector, we can measure the length of C and of course compare it to the one that you used to do the scaling. Okay, and of course the theta here using the protector is 45 degree. Okay, the sum of vectors is independent of the order in which the vectors are added. For example, a vector A is vector A plus a vector B, so you can actually get the same resultance of vector B plus vector A, because in the adding the vectors does not change any properties of the directions of the resultants. You can see here the R is remains the same length and also the same angles, the same directions. Remember one thing, for the directions part, okay, directions you can always tell us in terms of compasses such as north, okay, south, east and west. You can also using directions, okay, right, right, left, okay, top, bottom and so forth. And of course for the directions we can also state using angles, meaning that 0 until 360 degree. Okay, this is also is considered as angle or considered as direction. So remember, we can express the directions in terms of compasses and directions, maybe right to left, and of course the theta. Subtracting vector graphically, how to do it. So the negative of a vector is a vector of the same magnitude but pointing in the opposite directions. So if you have a minus a vector A minus vector B, so vector A minus vector B, if we can write down like this, okay, let's say you have vector A minus vector B, is actually vector A, okay, plus with the negative of vector B. Okay, what does it mean by the negative of that vector B? Meaning that here, okay, you can watch here that the negative, this is positive B. Okay, this one is the B. Okay, positive vector b. So this one is a negative vector b. You can measure here. Okay, the length of vector b is the same of the length of vector negative b. The length is the same, but the direction is opposite. So that is considered as subtracting vector graphically. So let's look at the one examples taken from your textbook. So we can have a car travels 20 kilometers due north and then 35 kilometers in the directions of west of north as in figures 3.6. Using a graph, find the magnitude and directions of single vector that give the net effect of the car's trip. The vector is called the car's resultant displacement. Okay, so using the same figures, so where is the first trip of the car, which means the car travels 20 kilometers due north. So according to the given compasses arrow directions, the north is going upwards. So therefore, starting from the Cartesian coordinate, now we have 20 kilometers due north. And afterwards, the car will travel 35 kilometers in the directions of 60 degree west of north. So where is the west of north? Okay, so we should put another imaginary compasses over here. So this is your north, this is south, this is west, and of course this is east. So what is 60 degree west of north? West of north. Okay, how to read and how to put the angle of 60 degree west of north, we should learn it from the back to the front. Okay, so we should put the angle between north, see, between north to south, between north to west. So where is between north? Here is north. Now it's going into a certain west, because we know west is over here. Now right now is 60 degree, and then of course you do the tip to tail methods from the beginning until the end, so that will give you the resultants value, the resultants line. Okay, so this is 3.2, the components of a vector. Before we learn it, just look at these examples or look at this situation. You need to walk west for a certain distance. Let's say you are at the 5th Avenue over here. Okay, you need to walk west for a certain distance, then turn and proceed north an equal distance until you reach the library. So meaning that here you is about a certain distance from this until the library. Okay, so right now we are seeing that the concepts of components of vectors. So we do have graphical methods to solve the resultants. Obviously the resultants we can get the resultants using graphical methods. So we already use tip to tail methods in order to fulfill the how to solve the problems of resultants. But we do have one more things to ensure to solve the problems in vectors by using the components. So what is components? Okay, so the components is actually based on the vectors. Let's say you have vector A over here. So this should be your vector A. Okay, the vector A is always come with the AX and AY, which means these always come with the components, its components. So the components is related to the one we actually put it as an axis. So let's say on the horizontal part, if the vector A, then we actually know that on the horizontal part will be a in the x-axis, vector A in the x-axis, and of course component at the vertical part is called AY, or should we know as vertical vectors, okay, or components of Y. on the x-axis. We should consider that vector A is the how to get vector A actually. So it's based on the component. Let's say you do have vector ax over here, certain number, and of course you have vector y over here. Okay, the length of vector y, what the ay, and of course there is a vector A, which means if we can consider ax as square and ay is square, so therefore A will be square. So this is what we call as Pythagoras theorem. Okay, because this is the hypotenuse of the triangle, meaning that if you want to find A, so what is A? What is vector A? Okay, vector A is considered as the square root of, okay, ax square plus ay square. So where can we get this one? This is because of the Pythagoras theorems. Okay, look at the angle. Angle is in between the vector and the x-axis. Vector and the components of x-axis. So therefore, components of x-axis now become a cosine theta. How can we get a cosine theta? Okay, so let's say this is your theta. Okay, this is hypotenuse, and of course this is opposite, and this is the adjacent. So how to get the cos theta? Okay, cos theta is equivalent to ax, okay, because cos is adjacent over hypotenuse. So adjacent over hypotenuse, ax over h. In this case, h is a. So therefore, ax is equivalent to a cos theta. Okay, ax is equivalent to a cos theta. So look at the angles. Okay, look at the angles. Where does they put the angle? If the angle is in between the vector and the components of x, then components of x will have cos. Okay, but if in the certain situation the angle has been put here, okay, in between the vector and also the vector, the components of y-axis. So therefore, components of y-axis will become cos. Okay, so don't get confused, right? So given the components of a vector, find its magnitude and direction. So basically, this is how you determine the magnitude, and this is how you determine its directions. Okay, so let's look at the examples here. Examples 3.2. Find the horizontal and vertical components of the d 100-meter displacement of a superhero who flies from the top of a tall building along the path shown in figures. Okay, so suppose instead of the superhero leaps in the other directions along a displacement vector b to the top of a flagpole where the displacement components are given by bx is equivalent to 25 meters, negative 25 meters, and by equals to 10 meters. Find the magnitude and directions of the displacement vectors. Okay, so we should determine first where we are given 100 meters displacement of a superhero who flies. So 100 meters displacement is considered as vectors. Okay, is flying from the top of a tall building along shown here like this. Okay, so each one is 100 meters. So that will be the magnitude of vector. Okay, so let's name it as A, vector A. So as 100, and therefore the theta is 30 degrees below the negative, below the positive x-axis. Remember, we'll still apply the axis over here. This one is x-axis, while the vertical part is the y-axis, and of course the horizontal is the x-axis and the vertical is y-axis. Okay, so meaning that we should find what is the ax and what is the ay. So noted here that AX is considered as A cos theta, and 100 meters cos negative 30. Why we are using negative 30? So don't bother about negative, it's just the value of trigonometry functions for the x. You can, if you are dealing with the somethings related to trigonometry function, please remember all the school days during where we learn about trigonometry. All students, sorry, all science teachers are crazy. Okay, this means at this meaning that at quadrant 1 all value will be positive. In the quadrant 2 only um, sine theta will give you positive value, and in the third quadrant only tangent will give you positive value, and on the fourth quadrant only cosine will give you a positive value. So that's why they are using negative 30, since this is below the x-axis. But cos negative 30 is always, because cos here we are using cos at this uh, quadrant, so it still give you positive value. So you can punch your calculator, you can try it out together. So how about delta ay is a sine theta, so 100 sine 30. So you don't have to put negative over here. Okay, you just know it because science part in the quadrant 4 definitely sine will give you negative. So you just punch your calculator 100 sine 30 and just put the negative at the answers, because you should know that at the quadrant 4, okay, the sign will give you negative. And of course, okay, try to bring, okay, that is for components, okay, because the part A saying what is the components, okay, the horizontal and vertical components of the vector A. Okay, and how about if we suppose is that the superhero leaps in the other directions along a displacement vector B. So there is vector B to the top of a flagpole, meaning that, okay, the superhero right now have against the directions, against the directions of the flagpole. Right now the superhero is going down, now is going upwards, okay, at the 25 meters, okay, 25 meters. So basically we have bx in the question already put negative 25 and the by equals to 10. So meaning that now for the B part, Superman like this, okay. And of course we don't have to get the components because it's already stated in the question. So just bring the value to this kind of equations in order for us to get the magnitude of the B. So the magnitude of the B is 26.9. Remember to square both values of Bx and By, and therefore the directions taken, okay, the directions based on tangent negative 1 by over bx is the equivalent to negative 21.8. Negative 21.8 is considered in the second quadrant, okay. Negative 21.8 is in the second quadrant, therefore, okay, so this should be 21.8. That's why I put negative, okay, because it means we have to minus 180 to the net 21.8, okay, so that we will know, okay, all the values of the direction is must base from the 0. Where 0? At the first quadrant. 0, 90, 180, 270, and goes back to 360, or equivalent to 0. So that will be it. So as I said earlier, we should know how to add the vectors using the components, but first you must know the concept now is we need to find the components of each vectors. Okay, you must x and y components separately, and of course lastly to get the resultant vectors, and don't forget about the angle or the direction. So let's look at this problem. So let's say if we try to deal with some things that related to A plus vector B, you should know that vector A will come with come with the vector AX, components of AX and also AY, together with vector B. It's also coming with BX and BY. So what should we do? So right now we should add the AY to the BY, and of course AX to the BX. Why? Because in order to get C, so you need to do some equation, which means CX squared plus CY squared. So what is CX? CX is AX plus BX. And what is CY? AY plus BY. Okay, so these are the questions that we did just now, but using the graphical methods. So in the graphical methods, we obtain C, the resultant vectors, as 8.75 meters, and the theta is considered as 45 degree. But that is all because of our solely depends on our drawing. But to get more accurate in terms of finding the right resultant vectors, so we should introduce to get we should introduce to use vectors components. Okay, so for the first time we can use AX. First, this part is called component of A. Okay, this one is for vector A, and this part is the components of vector B. Okay, you can set it up to get every value correct. Okay, look at the how we use for 5 meters and also 4 meters, and of course we use theta. Don't forget to use theta, because that will give you a trigonometry equations, and therefore when we have AX and AY, BX and BY, okay, we should get CX and also CY. And like I've said, so we can introduce to the magnitude, which means equivalent to 8.47 meters, and the theta is equivalent to 42.3 degree, much more accurate. So we are saying, we compare to both. Of course, there is some pros and cons. When we try to deal with some things that are related to, we try to use a ruler or maybe a protractor. Obviously, we may do some mistakes, and it will cost us like quite a value. Okay, and theta also have a different answer when compared to the one we calculate. So it is very useful for us to get to know these both methods in order to get the resultant vectors. But of course, the more important thing is you should know how to do a components of vector in order to get the vectors value. So a hiker, this is one example, another one example. A hiker begins a trip by first walking 25 kilometers, 45 degrees south of west. So I write down here 45 degrees south of west. Okay, and of course if you want to measure where is the 45 degree, so measure it or try to read it from behind, meaning that we should put the angles from west to south. Okay, from west to south. So 45 degrees south of west. Where is south of west depends on the compasses here. So this is the south, this one should be south, this one should be west. Okay, so this is 45 degree. So you should read, sorry, this south and this is west. So you should read from, you should give the angle from west. Okay, so we should be here 45 degree and about 25 kilometers. And the second day she walks 40 kilometers in the directions of 60 degree north of east. So now put the imaginary Cartesian coordinates. Okay, so we should know, so this is north, and of course north of east 60 degrees uh, north of east. Okay, 60 degree north of east. Pardon me, this is not south of west, but this is south of east. So this is east actually. Okay. So 60 degree north of east is another part. So we put here again. We read it from east to north. Okay, east to north, and then this is the place. And the question asks you determine the components of the hiker's displacement in the first and second days. So the first and second days, like I've said to you, okay, please try to get this kind of value in order for us to understand the concepts of components. Okay. And on the part B, determine the components of the hiker's total displacement. Therefore, we should apply AX and the BX and BY and also AY. So therefore, we get the total value of RX and RY. On the C part, find the magnitudes and the directions of the displacement from base camp. Therefore, we add together Rx and Ry square. Therefore, we can get 41.3 kilometers. And of course, don't forget the vector always comes with the directions, and the directions is 24.1 degree. This is about unit vectors. Unit vectors are dimensionless vectors of unit length, meaning that we can easily state the vectors, but we are using unit vector. How to use unit vector? So what is unit vector? When you deal with some things that related to vectors, so this is the vector. In italic, vector is A, so you can put like this, vector with the arrow. So maybe like I've said just now, we can put maybe 10 of x. So x now, meaning that the vector A have 10 units on x-axis. So that's what we mean as unit vector. Okay, so we are currently using x, the system of x. Okay, don't forget about the cap of the x, y with the cap, and also z with the cap. So we are using x, y, z, but maybe during your admax, you already see I, system of I, okay, j, and also k. So this is all the same, but we will learn some things. I always use XYZ systems. So 10 units in the x-axis, and if you have another 4y, so meaning that 4 units to y-axis. Okay, so everybody can look at what little Einstein said to the Isaac Newton about if there are d1x equivalent to 0 and d1y equivalent to 22 and d2x equivalent to 23.5 while d2y equivalent to negative 40.7. So little Einstein asked, can you guess what is d1 and d2? And of course, try to get d1 plus d2. Okay, so how can Isaac Newton solve this one? By not considering the unit vector. Of course, he must consider the unit vector because we want to state the vectors using the length and also the units contribute by its own unit vector. For example, for d1 we have 0i. Why 0i? Because we have 1x and another one is 1y. Okay, so 0 for 1x, d1x is 0, meaning that no I. Okay, in this case, our case, maybe no x. So you can write down as x plus with 22. Okay, see here, it's a positive 22, therefore they put 22j, j with a cap. And of course, for the d2, okay, they put 23.5i minus with, because the d2y have minus 40.7j. So this one easily 23.5x minus with 40.7y. Okay, and of course, if you want to measure it, then you should put it together, x with x and y with y. Therefore, we can get 23.5i minus 18.7g. This situation is very good when we try to deal with something related to magnitude. So this one, 23.5, just square it. Just square the value of 23.5 because it's already x exists. And negative 18.7 is already y exists. Therefore, the answer is 30. Okay, so this is quite additional to the informations we have when dealing with the vectors, because before this we already learned about how to add and subtract the vectors, but not the multiply the vectors. So actually for the multiplications of a vector, we may have to use a different kind. It's just not the normal multiplications, okay, like we did during addition and of course the subtraction of the vectors. But the multiplications of a vector have two approach. Number one approach is using the dot product. What is the dot product? The dot product is actually how you multiply vectors. Okay, you know the vectors should have directions. Okay, how to multiply the directions? You can easily multiply the magnitude but not the directions. So use these informations in order to understand the dot product. Okay, so x, if x times the unit vector x times the unit vector x, then it becomes 1. But while for x times the vector unit vector y, it becomes 0. So does with y times with x, it becomes 0. But y times y, it becomes 1. So we can conclude that if the unit vectors multiply with the same unit vectors, so you can get 1. But if the unit vector times with another unit vectors, so you will not get it, you will get nothing. So that will be 0. Okay. So that will conclude to give you ideas. So can we see the example? So this basically have the examples of vector A multiply with vector B using the dot product. Okay, the symbols is dot, big dot. Okay, vector A dot vector B. Okay, it's just a normal multiplication. It's just that we should know, okay, about how to multiply vectors when, how to multiply numbers when you have a brackets already. So now you have ax with the unit vector x and ay with the unit vector y, and you also have bx as a with the unit vector x and the by and the unit vector y. So don't when you try to multiply, so make sure the ax now you multiply with the bx. Okay, but not just ax and bx, you also multiply x cap. X cap multiply with x cap, so you get 1. So therefore you can, okay, so afterwards you multiply ax with the by, and of course not just ax times by, but x times y, the unit vector x, and of course times with the unit vector y. So you can obtain like this: ax bx xx, okay, plus with ax by xy. So definitely x times y will get 0, y times x will get 0, okay, and the rest is just only this one. So therefore that will give you, yeah, but because of that the dot product is called a scalar quantity, because in here there's no directions involved, no unit vector involved, there's only a single answer. Okay, so a dot cross a dot b vector a dot vector b, you will get scalar. Okay, what does it mean by scalar quantity? Scalar quantity have a magnitudes only. This is the examples of the scalar quantity of the vector dot product. The force shown has magnitude of 20 Newton, makes an angle of 30 degree to the ground. Calculate the work done. So work is actually will apply the dot product. So meaning that using that, okay, like they said inside the question, when the wagon is tracked 100 meters along the ground, so what is the value of? Alright, for the cross product, okay, so another types of multiplications of vectors is using the cross product. So what is the cross product? So the cross product is how in the end we will get maybe we will get the final answer. Maybe we can get scalar quantity or vector quantity. So there are two possible answers for the cross product, because when you have C, okay, let's say you want to find what is C, so there are vector C is vector A crossing. They use the X crossing. Okay, vector A crossing vector B. There is no dot product, so meaning we should use uh, vector cross product. So like this only, the answer should be A vector A cross vector B, because vector A is a vector and vector B is a vector. Therefore, both will give you vector quantity. Vector means you can leave this the answers like this, okay, because it's only considered vector quantity. Okay, but how about if vector A crossing vector B with the bracket? So with the bracket, then you may found that the A crossing B will be equivalent to AB sine theta. AB sine theta. Okay, so from here you can determine the value. So you will get the value, and of course, if you want to know where is the direction, you should use the right hand rule. Okay, as you see here, when A crossing B without the bracket, okay, which means the final answer should be a vector quantity. How to actually know that this one is a vector quantity? Look at the final value. Look at the final answer. It contains I, it contains J, and of course it contains K. So meaning that the final answer will be in the form of vector quantity. Okay, it will in the form of vector quantity. So you must know how to use this one. And for examples, use this kind of situation. If you want to get the I, get the value of in front of I, so you should, okay, do some things that related to AY BZ minus AY BZ. Okay, this one crossing this minus with BY crossing AZ. Okay, AZ crossing BY or BY crossing AZ, doesn't matter. Okay, so that is for I. If you want to get J, okay, the unit J, so you should do AZ BX minus with AX BX. So for the J only, so you do this part first, AZ BX minus with BX AX BZ AX for J. And of course, here is positive value, this one is also positive value, and for the K part, you do AX AY BY minus with AY BX. Okay, just look at the examples. So this is an examples for torque. Okay, so in torque we are using a vector cross product. So suppose the vector R, so meaning that if you want to get the torque is equivalent to R cross F. Okay, r is a vector while f is also a vector. So therefore we need to apply the triangles like a triangle solution. Then you should put that r have contained 1.2i plus 1.2k without j. Okay, and how about f? F is 150i only, so without j and k. So the rest of the non-numbers here you should put 0, 0, 0, 0, and therefore you will get here 180 meter Newton J. This one 0, this one 0. So therefore the answer is only 180 meter newtons, pointing to the J. Where is J? Along the positive y-axis. So this is the kind of final answers that stating magnitude and also directions. So that's it for chapter 3, part of the chapter 3, and to be continued on the next chapter. So stay safe everyone, stay focused and stay calm in learning physics. Thank you very much.